Somehow it's not, I can't really locate this link. Okay, amazing passcode. What do I call this guy? Okay, so let's, Bernie's supposed to copy this. Somehow it's not, I can't really locate this link. Amazing passcode. Okay, so let's see, can you use this? I mean, for the link, did you get a meeting passcode?
No.
All right. So the only problem is I know what's happening. I need to update the Zoom meeting link. So I put the records meeting. The meeting link will work, but the only problem is I can't locate this meeting anymore. So let's see how can I, or maybe change the date. That might help. So that should have say Matt Tambora summer reach out program. No, I don't call previous one. So let's go to my previous one, going back. Oh yeah, I find Matt Tambora Academy here. So now I need to get this guy meeting passcode. All right, passcode. Let me send him a passcode to 608 608 264. Okay, here we go. What's going on with this, guys? I gave the right link. What this is doing wrong? Oh, I gave it wrong link. Wrong links. Okay, so I gave it the wrong link. Hold on. Wrong link. How do I send this link right now? So let me copy this thing. Did I copy this? Okay. Let's post on Google Classroom. All right, guys. So I'm gonna moving back to my next unit because I did finish teaching the chapter 2. So I'm gonna start a new unit. What I will do at the end, I can come back to some questions on the chapter 2. What happened to my Zoom meeting? Zoom. Where's my Zoom goes? Oh yes, done. And let's people in. Yeah. Sharing my screen. Amina, can you see my screen?
Yep.
All right. I do have MCV for you, Matt Tambora. So let's insert this and insert. All right. PDF. So drive. So your teacher for physics doesn't give any handout?
No, he doesn't even do the slideshows.
He gives slideshow?
He doesn't.
So then how does he teach?
He talks the whole time.
He talk about physics all time or?
No. That's about other things.
Preaching?
Hi, sir. Can you hear me?
Yes, sir.
Okay.
Just give me a moment. Organized teaching notes. How did you do on the test, Matt?
I did pretty well. I got 90 on it.
That's pretty good. Is it chapter 1 test?
Yeah, chapter 1 test. We have chapter 2 test on Tuesday.
Okay. I finished chapter 2. I gave a practice test last class. I'm gonna move back to chapter 3. But if you guys have any questions, I'm gonna come back later. Okay.
So, yeah, I had one question, like 2
I'm gonna come back.
from the
I'm gonna come back to that after my just catching up on something on chapter 3 first. All right.
Oh, okay.
So what we're gonna going back to in chapter 3, 3.1. It's basically finding the higher order derivative. It's a pretty straightforward concept. What I mean by higher order derivative. The idea behind a higher order derivative is let's going back to y is equal to x squared. So the first derivative, you can apply the power rule, isn't it? What if I want to take the derivative of that? So we call it double prime. You apply the same rule. So if you find the derivative of that, 2 is a constant. Derivative of x is going to be 1. So it's going to be 2. Did you guys see the picture?
Yeah.
That's what it is. High order derivative. And then there's going to be used different sign. So the sign for it, y prime, double prime. And then when they use the Lagrange notation, this is going to be written as d2y over dx squared, d3y over dx cubed. Now let me call Brenny. Brenny's supposed to be joined. So what's going with the Brenny? I posted on the Google Classroom. Brenny's probably not in the Google Classroom. That's what he's going to say. Oh, what group chat? Oh my gosh, really? He doesn't know what is Google. I put Google Classroom as a group chat. Sir,
Hello?
I posted in the Google Classroom, sir.
Oh, wait, I'm not in the Google Classroom.
Yeah, I'm going to send you the Google Classroom link.
Okay.
Let me get the link directly. So I post it now on stream. So let's see. Oh, no. Stay participant. Leave the meeting. Okay, I need to give this. How do I get this copy link? Really, it doesn't do that. Participant. Let me send the Google Classroom link, sir.
Okay.
All right. This is going to be link copied. So you're done with the swimming class?
Yep.
Okay. If you join the Google Classroom, you can access it. So let's going back to see how we can find the first derivative. So you all are expert on finding the first derivative. So we're going to bring the negative 4x cubed. And we're going to bring the 2 to the front. 3 times 2, 6x minus. If you find the derivative of x, you all know it's going to be 1. And then derivative of the constant is 0, isn't it? Are you just following that?
Yep.
All right. So what is f double prime? F double prime, negative 3 12x squared plus 6, because the rest is gone. All right, let me get. Where is Varunish? You forgot the class?
I'm not sure. Do you want me to call her?
Yeah, just remind her. The class started. So f triple prime. So f triple prime, we're gonna find. Ronit, how are you, sir?
All right.
Yes, I'm talking about finding multiple derivatives. The first derivative, you know. The second derivative is basically applying the same rule for the first derivative. So for example, f double prime means minus 4 times 3, 12x squared. And then you got an x here if you just take the derivative of x as 1. Triple prime, you're going to take minus 2 times 2, negative 24x. And then 6 is constant, isn't it?
Yeah.
Now, if I do 4x, that is the fourth derivative, negative 24. Now, f5 is going to be 0, isn't it?
Yeah.
After that is going to be 0. We can really find the derivative further. You see the picture?
Yep.
Okay. So let's practice the derivative of f prime, f double prime for that one. Because you guys are expert, so I'm going to put you the Jamboard. So, right. Use it Spark. Didn't provide any practice test. Nothing. You say Indian guy? That's kind of why he's not teaching.
Even when he does, like, try to teach, like, who derive equations wrong and things like that.
Is it a real physics teacher?
God, I'm not sure if he says he is, but
All right. So I copy the link. Oh yeah. I need to make sure when I copy the link, you can access it. So edit. And that's right. So anyone with this link can access it. So the edit is going to be okay. Copy a link. Let me put that on the chat. So I don't like you write things on iPad, so I want to see you doing it on the paper. There's plenty of space. All right, so now you guys can see. Okay, can you guys find out f prime, f double prime, f triple prime for fs is equal to x cubed over x squared plus 1.
It showed me what I did wrong.
What?
Quiz.
What went wrong? I don't think that I made a mistake. You probably circled something
Yeah,
incorrect.
I think I did that. Three.
But you circled the wrong option, even though we got the.
Oh.
What?
You know, for what? You know how the product rule, you break the power down.
Yeah.
And you subtract the power.
Yeah. You didn't subtract the power.
I subtracted the power, but it was the wrong option. Because it was hiding. So this is how it was. It was hiding like this, so I thought this was that power to the 4. I didn't see that.
Well, I can help.
It's okay.
All right, so let's see how these guys doing f prime. Did you finish doing f prime, Swati? Did you finish doing f prime, the first derivative? Hello. Did you get the first derivative done? Amina, did you get that, Jambo?
Yeah, I'm doing it right now.
Did you get the f prime of x done? Hello.
I'm writing it. Can you
No,
see
no,
it?
I'm talking to Swati. Yeah, you're
Okay.
writing it, yes. Swati, it's the first derivative is done.
Yes, but I'm doing it wrong.
How do you know you're doing wrong? Let me see. You're assuming you're doing wrong. And you're right. Yeah, that's not correct. So I'm gonna write the rule for the quotient rule, okay? So if f of x is equal to h of x over g of x, let me write the rule. F prime of x. You keep the g of x, h prime of x minus. Okay, can you apply the rule correctly? It's about just using the rule. I want to see the work on there, man, on your paper. Come over here. Okay. Why do you want to sit down, man? It's easy. That's Pranit will sit down. So easy to pass the work. Oh my gosh. All right. What do you got?
Just check if I did it right. I don't think I did.
That's correct.
What's correct?
Yeah, you can simplify if you can, right?
Oh,
Yeah.
you want me to say that?
What do you think? Correct, but you put a bracket around x squared plus 1, right? Okay. All right, so I'm not sure whether I can see this guy's work. Abhinesh work. Let's see what Abhinesh is writing things in here. Oh yes, okay. All right. So I think that you guys got the idea what to do. Somebody popping up, or somebody left. All right. So you guys got the first derivative. So that's using the quotient rule. So first step, we're gonna be square x squared plus 1 whole thing squared. We're gonna keep x squared plus 1, find the derivative of that is going to be 3x squared. Minus x cubed times derivative of that is going to be 2x. I think that you wrote something incorrect. Hello. You keep the denominator squared, keep the denominator, find the derivative of the numerator, minus, oh, you change it. Okay. Now we can able to simplify that. So 3x to the power of 4 plus 3x squared minus 2x to the power of 4 over x squared plus 1 to the power of 2. Therefore, f prime of x is equal to x to the power of 4 plus 3x squared over x squared plus 1 to the power of 2, isn't it? Oh, you made it on time. Not bad.
On time.
Yeah, he was watching the lesson and then on time. Coming from the swimming class, this guy probably really tired.
It's very tired. You mentally prepared for this one? What, this?
Did you get your mutton biryani on the way? No.
This is very nice.
And here. All right. Now we're gonna going back to double prime. The double prime is going to be fun. So let's do the double prime. Of course, we're gonna square the denominator one more time, isn't it? We will keep the denominator as it is. Find the derivative of that. 4x cubed plus 6x minus x to the power of 4 plus 3x squared. We're gonna find the derivative of that. So 2 times x squared plus 1. And then go inside 2x. Make sense? Are you just following that?
Yep.
All right. So you need to simplify. So let's going back to how we can simplify it. So first step, we see x squared plus 1, x squared plus 1 sitting as in both places, isn't it? Did you guys see that? Hello.
Yeah.
All right. There's another place you can see there's an x is also sitting as a common factor. We will deal with that after the step. So I'm going to take x squared plus 1 as a common factor. So what I will left over with, I will left over with 4x cubed plus 6x, right? Minus 2 times 2, 4x again, x to the power of 4 plus 3x squared. And then x squared plus 1 has been taken as a common factor. I completely forget to multiply by x squared plus 1. So there's a 1x squared plus 1 will come here, minus 2 times 2 is going to be 4x. X squared plus 1 is taken out. X to the power of 4 plus 3x squared divided by x squared plus 1 to the power of 4. Any question on that step?
No.
So we can cancel these guys. Cube. Now it's up to you. If you want to take the x out or you want to work with that. I'm not worried about the algebra part. You can simplify it by foiling it. If you're foiling it, let me do one of them. We'll show the foiling it. So 4x cubed times x squared is going to be 4x to the power of 5 plus 4x cubed plus 6x cubed plus 6x minus 4x to the power of 5 minus 12x cubed. Isn't it?
So do we always simplify the one that we just like
Absolutely,
factored
sir.
out?
Absolutely.
Okay.
You have to leave the answer in a final factored form. Otherwise, you are screwed.
Okay. No, I'm talking about, you know, the how you're simplifying right now. We have to do that step, right? Or is that optional?
That's a step.
Okay.
Otherwise, you can't get the final answer. Simplified factored form. 4x cubed plus 4x cubed plus 6x cubed, 10x cubed minus 12x cubed is going to be negative 12x cubed plus 6x. What we don't like it, we don't like the negative sitting in the front. Also, we don't like the x. Oh no, we don't like the 2x. So if I take that out, you're going to have x squared minus 3. You guys see the final answer? So how the answer will be written, minus 2x times x squared minus 3 over x squared plus 1 to the power of 3. Are you guys following that?
Yeah.
Well, I'm not really worried about taking another derivative, but you need to know the idea behind the higher order derivative, isn't it? The idea behind the higher order derivative. So, Varuni, how did you miss the class? It started 11:30. Where were you? Varuni?
Yeah, I kind of forgot we had class today.
All right. Another student in the morning. Class started at 9 o'clock. I need to text her mom. She came back. What happened? I was distracted by the time.
How does that make sense?
Anyhow, okay. By the way, I'm not, well, I'm away for March break, but not on the weekend. So why my class on the weekend still continue.
What?
But you guys want to learn something ahead of time or not?
No.
Huh?
No.
Then you don't need to come. So my Saturday class still continue. The only class I think that I will miss here most probably. We
Okay.
plan to go on Wednesday and Thursday. So if you guys are free in the morning, I will catch it up.
Okay.
Right. So we can discuss that next week. Oh, we have one more week. March break is the week after. But next week, Saturday class will happen. The next week, Saturday class, yeah. All right. Well, that's the time to catch up on a lot. So going back to the next one, I think I did put the link for Barony again, so you can access the chat. I have kids telling me, so keep everything as easy until midterm. After that, we don't care. I say, sure. After
That's
that,
literally everyone.
right?
Pearson, everyone's like you're going to do that.
What?
They're just gonna vote like lock in for midterm and then they're just gonna forget about it.
I will make sure until
Final term is when they're checking everything.
yeah, I will make sure until midterm make it harder. After that, I'll make it easy. All right. So we're gonna going back to find f to the power of n. So this is interesting. Why it is interesting? You see that they want to the power of n. So they didn't say 1 or 2 or 3, just power of n, isn't it? So we want to go back step. Let's find out f1 of x. So what do? X plus 1 whole thing squared. You keep x plus 1. You find the derivative of x is 1 minus. You keep the x, you find the derivative of x plus 1, which is also 1. Look like x and x gone. Isn't it? I got 1 over x plus 1 whole thing squared. Are you guys got that picture? Yes? So are you following that? I can rewrite that x plus 1 to the power of -2. Because now I have 1 over. So how do you get f double prime of x? -2. X plus 1 to the power of -3, isn't it? Makes sense? Are you guys following that? Hello?
Yeah.
Yeah.
F double prime of x. -2 times -3, +6, x to the power of 1 of -4, isn't it? Makes sense?
Yeah.
But I'm gonna do a little change here. I don't really want to write that way. I'm gonna rewrite here -2 times -3 times x plus 1 to the power of -4. Therefore, f to the power of 4x, -2 times -3 times -4 times x plus 1 to the power of -5, isn't that? Hello?
Yeah.
Hi. Are you following that?
Yeah.
Yeah.
Okay, I'm gonna leave you guys to get an expression. It's gonna be fun. But I can still write in here in front of it, because multiplying this -2 -3 by 1 doesn't make any difference. And also multiplying this one by 1 and you make difference. So I can rewrite my x to the power of 6x by skipping the 4x. Watch the pattern. 1 times -2 times -3 times -4 times -5 times -6 times. When it's 4, it's -5. When it's 3, it's -4. And 6 is supposed to be -7, isn't it? Are you seeing a relationship?
Yeah.
Everyone seeing a relationship? Yeah, yes.
Yeah.
So what is f to the power of nx? 1 time, -2 times -3 times -4 times -5 times -n time, yes. X to the power of, when it's 6, you put minus, there's going to be n plus 1, isn't it? 6 became 7. N became n plus 1 with a negative sign, isn't it? Hello?
Yep.
Now, let's look at something here. When you have a 2, you got a negative. When you got a 3, it's going to make it positive, isn't it? Make sense? Are you
Yeah.
seeing that? Hello?
Yeah.
All right. So what I'm gonna do, we're gonna be write some interesting result here. This is x to the power of negative n plus 1, right? Forget about all the negatives now. If you forget about all the negative, what did you get in front of it? What did you get in front of it? If you ignore the negative, 1 time, 2 time, 3 time, 4 time, 5 time, all the way up to n, isn't it? In advanced function, your teacher has called this Abhinav. What is that equal to?
The sequence?
Sequence. There's a name for this.
Like you're
One time
asking.
Huh?
Wait, I don't get the question.
What is this one is equivalent to? What is the another way to simplify that? 1 time, 2 time, 3 time, 4 time. You said your teacher didn't teach when I did that exam review on December, and we talk about this. What? Correct. N factorial. That is an n factorial time x to the power of n plus 1. I mean, with the minus sign, isn't it? Are you just following that?
Yeah.
Avinash, are you seeing that, sir? 1 time, 2 time, 3 time,
Yeah.
4 time?
Yeah,
Now
we
this
learned
is
n
still,
factorial.
but there's something is missing. So what is missing here? There should be something in the front. It should be negative or positive, isn't it? Okay, so n factorial time x to the power of negative n plus 1. So I need to multiply by this by something. So of course I need to multiply by negative 1. And then we're gonna see what to rewrite this. So I need to write something here. I need to write something here. So how I'm gonna write is something. There's a couple of ways I can do. Negative 1 time, so one option. So there's gonna be piecewise function, or n factorial time x to the power of negative n plus 1. So let's going back to see, when do we get positive? We got a positive expression when the n is odd. Did you guys see that? F triple prime x is going to be positive, isn't it? You see that? So we're going to say it is going to be negative when n is even. It is going to be positive when n is odd. So I will get a negative 1 in front of it when n is even. I will got positive when n is odd. We can see that from the pattern. Did you guys see that? Hello.
Yeah.
Of course, at some school, you didn't learn series and sequences in grade 7. Did you learn series and sequences?
I don't think so.
Arithmetic series, geometric series, arithmetic sequence, geometric sequence.
I don't remember doing that.
Unfortunately, your teacher have told you, man. I know that you did pretty well on the test. You have been keep on bombarding on the test, and then you did pretty well on those tests.
Yeah.
Missed
Wait,
yeah.
why don't they teach it at other schools? Did you teach it?
Because our school, we spend more time on teaching them grade 10, 9 and stuff in the beginning, and then we end up with having more.
All the Asian kids at our school.
All right.
All the Asian kids at our school.
Okay, so well, let's move back to the next question. Veroni, are you seeing what's happening in this question?
Yeah.
All right. So let's go back to the really good one. Are you guys ready? Hello.
Yeah.
All right. All right. Let's have another one. So that the following satisfy this equation. Now let's going back to something you guys are gonna see. If you're gonna major in engineering, or if you're gonna go back to any field that's required some mathematical modeling, you will learn how to go from here to here. To go from here to here is in math is known differential equation. That process is called differential equations. Without differential equation, there's no way a high-level modeling, mathematical modeling can happen. But we're not going to differential equation. We're gonna going back to just what we know to show it. All we need to find out is, we see that there's a triple prime, double prime, and single prime. Let me find triple prime. 3x squared plus 2x is an, no, double single prime. Anyone watch the comedy show yesterday? No one watched the comedy show yesterday. It was fun. Did you watch the comedy show? The whole world was watching yesterday.
What comedy show?
Come on. What?
The election?
Election is a comedy show?
I don't know.
Yeah.
Maybe, yes. Yeah, that's also a comedy show. For sure. How about Varuni, Avina, and Avinesh? Did you guys watch the comedy show?
No.
Is it the Donald Trump thing?
Yes, Donald Trump thing.
Oh,
Donald
yeah.
Trump. He invited the Ukrainian president, and then he just say that I'm going to be peace negotiate him in public in front of the media. And then it's like that my grade 10 kids get upset with the teacher. I don't want to put the phone away. They're saying, no, you're going to go to the office. Same thing. The vice president of the United States told the Ukrainian president, he asked, how many times you said thank you during this meeting? You guys need to go and watch that. The whole world is watching yesterday that two teenagers fighting against Ukrainian president. Anyhow, so let's go back to double prime. 6x, triple prime, 6. So far so good. Hello.
Yep.
Let's
Yeah.
substitute. Y triple prime plus x times y double prime minus 2. What is y triple prime? 6. X. Well, x time double prime. What is my double prime? That is 6x minus 2 times what is y prime? 3x squared plus 3, isn't it? 6 plus 6x squared minus 6x squared minus 6. Tack, 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 tack. That is equal to the right hand side. You guys see that? How do you prove it? Simply we substitute the results back to the original equation, isn't it?
Yeah.
Yes.
Okay. So the reason why we are learning the higher order differentiation, it has an application, especially in physics, and especially in physics as an application. So let's go back to a simple example. So if you have a position time graph, if you take the first derivative, you're going to get that velocity. Second derivative, you're going to get the acceleration. So the question says, consider the following position time graph on the same grid. I don't want to find a graph. We're going to find that v of t. So what is v of t is going to be? S prime of t, isn't it? We can common factor the 1/4. 3t squared minus 12. What?
VFT is what, velocity?
V of t is velocity. Yes, sir.
And A is acceleration.
Correct. So A of t is equal to v prime of t or s double prime of t. So we need to take the derivative of that function again. 6t. That's it. I can simplify that, but I don't really want to. So they ask, consider the following function, graph on the same grid. Well, one is a cubic function, another one a quadratic function, another one linear function. But that's not what I really want to talk about. We're going to going back to how do we use this to solve a problem. Find the interval when the particle is moving forwards towards the origin. So find the interval when the particle is moving toward the origin. So moving towards the origin. So this is the origin. Away from the origin mean v of t is supposed to be positive. I mean, away from the origin mean the acceleration is supposed to be not v of t. Acceleration is supposed to be positive, right? Oh, we can also think about that s of t. When the displacement is going to be greater than 0, it should be moving away from the origin. When the displacement is going to be less than 0, is negative, it's moving in the opposite direction. Now, you guys find that? Yes, sir.
How is VFT? Why is it 1/4?
Well, v of t is 1/4 because s of t, in s of t, there's a 4 here. I took the 1/4 outside. So for this one, we're going to put s of t must be less than 0. So what is my s of t? I don't really need to teach how to do this, isn't it? When did you guys learn, Swati, how to solve for that?
Grade 11 advanced function.
Grade 11. You said grade 11 advanced function?
I'm sorry,
That's
sorry,
okay.
grade-
Okay, grade 12 advanced function. Yes, so we can cross multiply. T cubed minus 12t less than 0. We're going to common factor t. T squared minus 12 less than 0. So we had to put that back into our little chart, isn't it? Yes, following that. So 1 is going to be, of course, 0. Now we need a factor that t
So
squared
why do we only use the ST, like the ST
So in
formula
phys-
instead of the VT?
in physics, sir, when an object is moving to the right side, it's moving away from, moving to the left side towards. So this is the origin. Make sense? Now you
Yeah.
have learned grade 11 physics and grade 12 physics. What I didn't do this, if V of t is going to be, let's see A of t. If A of t is less than 0, you can still move on the same direction. You're slowing down. That's what the acceleration is. So let's say I have a car moving this direction, right? When I apply the brake, if the car moving backward, what will happen?
Someone's gonna get killed.
Exactly.
Wait, is the train going backwards?
No,
What, is
I'm
that
answering
going
his
forward?
question that why we didn't use AFT. Imagine that AFT is negative when you apply the brake. The car started to move backward. What will happen? Right?
I don't get it with these physics teachers.
All
They do
physics
the most
teachers-
unpractical things ever with their tests. They write a train question and that's just going backwards.
It's going.
It never goes the right way.
And yeah, did you guys see that? Why do you go back to SFT, not the other ones? Guys,
Yep.
hello. All right.
Yeah.
So so we need to factor this t squared minus 12. So how we're going to factor t squared minus 12? Actually, what we can also do, one more thing, you can also say v of t is less than 0. So v of t is less than 0. So when the velocity is negative, definitely you have to move backward. So when the velocity is negative, you're moving backward. So you can also use the v of t. So let's use the v of t. I think that using v of t is much more easier than working with this, because v of t is a nice function, 1/4 3t squared minus 12. I can pull the 3 as a common factor, 3/4 t squared minus 4, isn't it? So I want that to be less than 0. So t squared minus 4 must be less than 0. T plus 2 times t minus 2 must be less than 0. So that is going to be my chart with minus 2 and 2. So we got t plus 2. When t is positive, when t is greater than 2, positive. When t is greater than, my bad, when t is greater than negative 2, positive. When t is greater than 2, so this is going to be positive interval, this is negative interval, this is supposed to be positive interval, isn't it? Are you seeing that picture?
Yep.
So let's tell, when t is between -2 to 2, the object is moving towards the origin. But absolutely time cannot be negative. So that means between 0 to 2 seconds, the object is moving towards the origin. Makes sense?
Yeah.
All right. I think that for the next question, we already did this. Find the interval when the particle is speeding up. So let's ask Swati, who's learning physics from a great teacher. Okay. What does speeding up mean in physics?
It's accelerating.
That's right. So we have an acceleration function. You can see when time is greater than 0, you're speeding up. Very straightforward there. Everyone seen the picture so far?
Yep.
All right, so that's basically the higher order derivative. So I think that we did pretty good amount of higher order derivative. There are some questions we can do. All right, so we're gonna going back to, there are some textbook questions, homework. This is just defining a different function. So there are some textbook questions here, but let's see, are there any difficult question on textbook with higher order derivatives? So, (3.1). So this is my 3.1 velocity and acceleration problem. So this is pretty straightforward. I don't think there will be anything fancy here. Okay. So explain and discuss in the difference time. Explain and discuss the difference in velocity at times t is equal to 1, t is equal to 5 for that. Determine the second derivative. Absolutely, you got some different functions. You know how to find the second derivative, so that shouldn't be a problem. For each one of the following position function, describe the motion of an object along the straight line. Find the velocity and acceleration of the function. So all you have to do is you need to tell whether the object is at rest or if the object is going to be accelerating, deaccelerating. So we can do one other question here, S of t, 5t squared minus 3t plus 15, right? So let me write it down. S of t is 5t squared minus 3t plus 15. So let's show you what to do. So S of t is 5t squared minus 3t plus 15. V of t is S prime of t. This is 10t minus 3. A of t is S double prime of t, which is going to be 10. The good news is the object is moving with a constant acceleration of 10 meters per second squared, isn't it? Do you see that? Hello. The object is moving. Now, when they ask to describe the motion, so we can see that object is moving with a constant acceleration, 10 meters per second squared. Of course, from the beginning, there's no further discussion I can put. For each one of the following positions, describe the motion. So that's it. Because t is greater than or equal to 0, when time is greater than or equal to 0, we clearly see the object is accelerating from the beginning because there's no t attached to it, isn't it? When a t attached to it is a different story. We have to tell what time interval is accelerating, what time interval is deaccelerating. So number 3 is pretty straightforward. Let's go back to 4, answer the following questions for each position time graph. So let's see if you guys can see that picture. So let's say Varuni. So for the graph A, when do you think Varuni, the velocity is 0?
At 3.
At 3, correct. So why do you think at 3 the velocity is 0?
Because then the slope will be straight. And that's
Slope is straight. And then how that helps you? When the slope is straight, what does that mean? You say slope is straight. Okay, I will keep the word.
the tangent.
Tangent, okay, yes. So I'm not sure where to put this. It should become somewhere. Okay, so when the slope is 0, what do we know? Rate of change is 0. The rate of change in displacement time graph is the velocity. Velocity is 0. So when the velocity is 0, when time is equal to 3, isn't it? Now, when the object is moving in positive direction, when the object is moving in a positive direction, the slope must be positive. So from 0 to 3 seconds, it's moving with a positive direction. Oh yeah, 1 to 3, so 1 to 3, yes. The graph started 1, correct. When the object is moving in the negative direction, 3 to 5. So Swati, can you tell me when the object is at 0 or when the velocity is 0 for this graph?
At 3.
Correct. And then?
At 7.
Yes. So, Avina, can you tell me in which interval the object is moving in a positive direction?
From 0 to 2.
1.
And then,
No, it's not 0. It started 1.
oh, sorry, 1 to 2.
Yeah, 1, 2, 3, because that is 3. Slope is still positive until 3.
1 to 3, and then from 7 onwards.
17:30. So this graph would just keep on going. I don't know what the time is. So 7, the arrow marks just keep going, isn't it? Abhinesh, when do you think the object is moving in a negative direction, sir?
It's from 3 to 7.
So that's 3 to 7 is negative direction, isn't it? Okay, it's pretty straightforward there. All right, so particle moves along the straight line, determine the particle velocity and acceleration. When does the motion of the particle change the direction? So when it's changed the direction, your displacement can be negative or your velocity can be negative. When does the particle return to initial position? When the particle come back to the initial position, the displacement must be 0. Make sense? Guys, are you guys following that? Hi.
Yeah.
Let's see what the thinking question is. Oh yeah. The position time relationship for the moving object is given by show that the acceleration is constant and find a time at which the velocity is 0 and determine the position of the object. Determine the position of the object when that occurs. That should be a good question to work with. 15. All right. I'm just going to work it out, but you need to do the practice, right? You guys need to do the question again to see if you can do that. So let me show you how to work with that. So we want the acceleration is constant. So how do I show why the acceleration is constant? What I need to find?
Velocity?
Did you find a velocity? You can find the acceleration? Like what we need to find out in terms of the derivative that we're talking about. But how do I find AFT, sir? What is AFT is equal to? SFT is velocity, sir. Barone, S double prime of t we need it. So to do that, we're going to do S prime of t. So that is going to be 2kt plus 6k squared minus 10k. And if you find the derivative of t is going to be constant, 2k's disappear. When you find the S double prime of t, the t is gone. So you got 2k plus 6k squared minus 10k, which is 6k squared minus 8k, isn't it? Make sense? So that is a constant because it is not depends on t, where a is a non-zero constant. So k is greater than 0, right? Therefore, S double prime of t is going to be a constant. Can be negative or positive, you don't care. It depends on the value of k. Now, find the time at which the velocity is 0. So we have to be really careful. They're talking about a velocity is 0. So we need to go back to the velocity function, isn't it? So 2kt plus 6k squared minus 10k is equal to? Let's move things to the other side. T is equal to 10k minus 6k squared over 2k, isn't it? Are you seeing that?
Yeah.
Hello. Okay. So that is going to be, we can factor the k out. So it's going to be 10 minus 6k divided by 2. I can also further divide by 2, 5 minus 3k. So when t is equal to 5 minus 3k, object will be at rest, isn't it? Velocity will be 0. Now, the question has to find out, determine the position of the object. So to do that, you need to find an S at 5 minus 3k. So k time 5 minus 3k whole thing squared plus 6k squared minus 10k times pi minus 3k plus 2k. Are you guys following that?
Yeah.
We find the time at which the velocity is 0, right? And then we can use that time to find a position. Avinash, are you following that, sir, what the logic is?
Yeah.
Varuni, are you seeing the picture, Varuni?
Yeah.
Okay. All right. Let's moving back to next one. So I did take it up. Good questions. All you have to do is practice the rest. I decided this time my parents teacher interview my strategy. I'm going to borrow the notebook from Gauri and then Dibash. Keep the notebook when the parents comes in, grade 12 class. Can I see your son or daughter's homework notebook, please? So what else I can do?
I'll bring my iPad if you
I
want.
will need it. I can literally show you.
Okay, we're gonna moving back to guys. So I'm in high order derivative. So I'm gonna insert my next handout here. All right, insert. We have 7 more minutes to leave, right? Avina?
Yep.
Okay. All right. So we're going to moving to talking about something called something you have seen before in advanced function, but we're going to use calculus. So global maximum, definitely you have seen that keyword. Global maximum, local maximum in a polynomial function.
This was last year, no?
What?
Wasn't this last
It's
year?
the same as, but we're going to see in calculus. So let's going back here. Definition. A function f has a global maximum at x of c. For every single value in the domain in x, the f of c is the largest value. So we're going to going back to do this. For the find the extrema for the function represented in the figure below. So what we're going to do, we're going to find a local max. So the local max are going to be, this is the maximum point, x is equal to -6, right? This is also a maximum point, x is equal to 1. Make sense? This is also a maximum point, isn't it? Are you following that?
Yeah.
Hello. All right. So we got those points to be the maximum point. Any lower points that we're going to see is going to be the minimum point. So we're going to going back to list it. So we're going to going back to, well, out of that, one of them is not a local max. So of course, this is not a local max because that's the maximum among all of them, isn't it? So we're going to going back to the global maximum. So those are the local maximum, global max, maximum max. Global max is 6, 7. Make sure you give the coordinate and the point. So let's rewrite this. -6, 2, and then 1, 5. That's the global max. All right. So I mean local max. So we're gonna moving back to now. Next one. What is the global minimum, Avina? What is
It's
the global?
2, -2.
-2, -2, isn't it?
Yeah.
Okay. But I do have some local minimum, local min. So what are the local min we got? So the local min points are 2, 1. Yes. And then that's going to be the local min because that's going to be the global max. That's going to be a local min. Are you guys following that? How do we list them out?
So would E not count?
Oh yeah, E does count. I missed it. So, oh no. So the question here is, does the E count? No, E is not count. So let's explain why it is. So the idea here is when you want to find the when you want to find a local max or global max. So let's going back to the definition. Global min. A function f has a global minimum at x equal to c if for x is f of x greater than or equal to f of c. So that means all the x values are, if all the x values are larger than that, we're going to see f of c. But you're right, I missed the e. So that's going to be my minimum point. Where is that? And my local min, I missed the 5,2. All right. So now what we're going to going back to C. We're going to going back to how do we find this global max or global min? So we're going to see the process. I'm going to show you how to do, guys. Pretty straightforward. First step. If you can see, in some of that local max, you're going to get a slope of 0. You guys see that? In a maximum or in a minimum point, slope can be 0. Right? But the graph also will have its own maximum value. For example, here, the graph has its own maximum value. That's the largest value the graph can take. So let's going back to see the algorithm. To find a global extrema for a continuous function over the interval a comma b. Identify the critical number. Find the values f of c at the critical number happening. Find the value at f and f at b. From the value from part 2 and part 3, compare the values. C is the critical number if f prime of c or f prime of c does not exist. In both ways, it's a critical number. So let's do that. F prime of x. 12x cubed minus 12x squared, isn't it? Any question with that?
No.
Let's head back to 0. 12 is a common factor. Actually, 12x squared is a common factor. So x is 0, or x is 1. All we're going to do is we're going to find f at 0. We're going to find f at 1. We're also going to find the endpoint, f at -1. We're also going to find f at 2. F at 0. It's simple as 0. F at 1. So 3 minus 4, which is -1. F at -1. 3 plus 4, which is 7. F at 2. 3 times 2 to the power of 4 minus 4 times 2 to the power of 3. 2 cubed is 16, 48. 2 cubed is 8. 8 times 4, 32. Let me highlight that. Let me write the coordinate. So we got the coordinates. We find out 0, 1, 1, -1, -1, 7, 2, 16. Which one is the smallest among them? Which one is the smallest y value among them, guys? Hi. That's the smallest y value, isn't it? So that's going to be your global minimum. Global min. What is the largest among them? Global max. We don't really worry about that. So all we need to do is the global max. Ivana, did you follow that?
Yeah.
All right. So you can leave. I believe that that's what the main piece is. I'm going to go back to the other exercises being recorded.
Okay. Thank you.
No problem. So see you on Wednesday.
Yeah.
All right. Next Wednesday, we're going to have a school shirt. And then we're going to have a class. Next Saturday, we're going to have a class.
Oh, yeah.
We're not going to have a class. So our classes continue. That I do teach them. One of them physics. The other one is.
So my Tuesday and Thursdays are canceled?
Your Tuesday and Thursday, I'm going only on Wednesday. So you can come on Tuesday. I'm going on Wednesday and coming back on
I
Thursday.
might be sleeping.
All right. Are you guys ready to get the next one? Abhinesh, are you following that, sir?
Yeah.
Oh, that's the end of the handout for 3.2. Oh, yeah. Let's do that. You all good? Swati, all good? Sir, all good? All right. So we can finish this and going back to some chapter 2 step. First step, let's find an f(n) -1. So -1 squared -1 over -1 squared plus 1 -1 squared, that is 0. Let's find f at 3. 3 squared minus 1 over 3 squared plus 1. 3 squared is what? 9 minus 1 AU. 3 squared, 10, 4 over 5. So we got a negative 1 comma 0. We got 3 comma 4 over 5. Next step, we need to find the f prime of x. Surprise, you still have so many kids on a smaller class.
I don't think anyone's gonna drop her.
What? Why? She's nice.
No,
So,
it's pain.
Hmm?
It's pain.
what?
I don't like how much pain.
2x cubed plus 2x minus 2x cubed plus 2x, isn't it? Are you just following that? Hello.
Yeah.
Okay. To find a critical point, we set this one back to 0. We can cross multiply by the denominator, but these two gone. So you got 4x is equal to 0. So therefore x equal to 0. So what is f at 0 is equal to? 0 minus 1 over 0 plus 1, which is negative 1. So we get another point 0 comma negative 1. All right, so you should be able to tell based on that, the minimum among all of them is 0 comma negative 1. The largest among them is going to be 3 comma 4 over 5, isn't it? Bravo. X is 3 comma 4 over 5. Global min. Colin is talking over with Vijay Thaniasalam and
What is he posting?
Vijay Thaniasalam posting. And then with Logan.
He complains about people not paying taxes, the government taking those taxes,
So what's
using
that?
it for personal uses. And he's like, here I am doing everything legally, and I'm paying taxes to the government. They're just taking it. Like, don't pay taxes. That's what they're doing. Just don't pay taxes. Man.
All right. You guys good with that?
I don't like taxes.
All right. So next question, find the extreme. I try to do the example when you guys gonna do the question. So we're gonna find it f at 0. So 0 plus 1 whole thing squared time cube root of 0 minus 1. So which is 1 time minus 1, which is negative 1. And f at 1/2. 1/2 plus 1 whole thing squared time cube root of 1/2 minus 1. 1/2 plus 1 is 3 over 2. This is negative 1/2 to the power of 1 over 3. Isn't it? Everyone see the picture? All right. So that is 3 squared over 2 squared. That is negative 1 to the power of 1/3 over 2 to the power of 1/3. Negative 1 to the power of 1/3 is negative 1. So 3 squared is going to be 9. So negative 9 over 2 to the power of 2 and 1/3. 2 plus 1. 2 to the power of 7/3. Well, we need to simplify that. You can use a calculator to find it. What is that number is? All right. Or you can put the whole thing. 3 divided by 2, whole thing squared times it. So I got negative 1.78. Negative 1.78. So let's list the coordinate. 0 comma negative 1. 1/2 comma negative 1.78. What next steps, Vladi?
F prime.
That's right. We need to find the f prime of x. So let's rewrite this little nicely. X plus 1 to the power of 2. X minus 1 to the power of 1/3, isn't it? What rule we had applied to find that, Baroni? Baroni, which rule should I apply to find f prime of x?
Power rule.
Power rule. Product rule. You're going to apply the power rule, but you need to use the product rule.
Yeah.
F prime of x. Let's keep this guy as a constant. Keep that x minus 1 to the power of negative 2/3 plus x minus 1 to the power of 1/3, 2 times x plus 1. So x plus 1 whole thing squared over 3. Makes sense? Are you guys following that? Can we simplify this? So 3 times x minus 1 to the power of 2/3 is the least common multiple. So x plus 1 to the power of 2 plus 3 times x minus 1 to the power of 2/3, x minus 1 to the power of 1/3, 2 times x plus 1. So that is 3 times x minus 1 times 2 times x plus 1. We're going to set this one back to 0. So the denominator is gone. So you got x plus 1 whole thing squared times 6 times x squared minus 1. Right? Makes sense, Pranit? Let us solve for x. X squared plus 2x plus 1 plus 6x squared minus 6. 7x squared plus 2x minus 5 is 0. Can we factor it? 7 times 5 is 35. Oh yeah, 7 times 5 is work. Let's work out nicely. 7x squared plus 7x minus 5x minus 5. So I'm gonna leave you guys. Can you guys find that f of x and using those points and tell me which one is the global max and global min? So let's see if we can do that. Substitute those points and find the f of x. Abhinesh, are you following that, sir?
Yeah.
Cool. There's a one thing also we need to talk about, guys. You guys see that it is not defined at 1, isn't it? So x is equal to 1, also a critical point. Make sense? Yes? You need to calculate that too. So in addition to solving the equation, you also need to find that out. I need the final answer that what is your global max and what is the global min?
Do we keep it as a fraction or do we have?
You can use a calculator to simplify. What is that? Your physics? What do you have? Oh, that's my optimization handout. Okay. So who has the answer?
You have to get a negative on this game.
All right.
But it's a cubic, so
Oh yeah. Sure.
Varuni, do you have the final numbers?
No.
Working on it?
Yeah.
I don't know. I think I did it wrong.
You know, I'm missing my actual tutoring place I used to, so I can have my midwifery.
you have it here.
Right? Where?
Just go upstairs.
What?
Just walk upstairs
Walk upstairs to where?
and eat. Oh.
Yeah, my midwifery, man.
Wait. Why do we have to calculate 1 again?
Because the denominator has x minus 1. So the critical points are the where it's f prime of x is 0, also where f prime of x is not defined. How's it going, sir? Abhinesh.
I'm still trying to figure out the points.
Okay. I already did the derivative for you. So the only thing you need to do is substitute an f of x, right? You don't need to do any additional work.
Okay, question. What if the y value is the same? Which one would you choose as the global?
Then they both.
They're both?
Yeah. I'm not sure how did you guys get 3.2 numbers. So you have to calculate, guys, f at 1. So let's going back to find f at 1. F at 1 is going to be 1 plus 1, all things squared, and square root of 1 minus 1. That is going to be for sure 0. So we get a 0.1 comma 0. You also need to calculate f at negative 1. Negative 1 plus 1 whole thing squared and cube root of negative 1, negative 1. We don't care, that is also 0. So negative 1 comma 0. We also need to calculate it at f at 5 over 7. I don't know, what did you guys calculate? Anyone have the number? What do you have?
Negative 1 is 0.
Say f at 5 over 7, what did you get?
That one is
Minus 1.936. So that is 5 over 7 comma minus 1.936. Obviously, that is going to be the global minimum, isn't it? Make sense? Yes? Are you following that?
Yeah.
Guys, yeah, and the global max supposed to be the 1 comma 0.
to look at the X value.
No, it's a maximum or minimum. When you do the quadratic function maximum or minimum, what did you do? Did you look at the X value or did you look at, okay. All right. Now, something we need to think about here. So we got a minimum point. Something we really need to be thinking about. That's not quite the answer, and I'm going to tell why. So I'm going to be just take this ones. Let's go back here. They want all the points in the interval 0 to 1/2, isn't it? Do you guys see that? Hello. 0 to 1/2. This is not in the interval, the X value. This is not in the interval, X value. Makes sense? So we have to ignore it. So if we ignore it, the only point on that interval is 1/2 comma negative 1.78 is going to be global min, isn't it? Make sense? Yes?
Where did you?
We got that in the beginning, man. If it's right, and then the maximum is going to be 0 comma minus 1. So max is going to be 0 comma minus 1. So very important. After you calculate it, global. After you calculate it, very important. You need to check whether it's falling within the range, isn't it? Makes sense. I don't think so. Your teachers will come to this next week, because next week you guys gonna
we're starting on Monday.
What?
We're starting unit 3 on Monday.
When is your test?
Thursday for unit 2.
And your teacher will come down. Okay. So I do have a textbook question, but what I want to go back, going back to the last section on this unit. So what we're going back to the next one is called optimization. We'll do the practice questions next week. Optimizations. What is optimization? So let's going back here. Y is equal to x squared plus 6x plus 8. How would you find the maximum value of this function? Or maximum or minimum? Swati. What would you do? While you're thinking, I'm going to ask the same question. Barony, how would you find a maximum value of that function? What would you do, sir? Avinash?
Wouldn't you just like find the vertex which you can use
Correct.
complete the square?
Exactly. So you're right. X squared plus 6x plus 9 minus 9 plus 8. Y is equal to x plus 3, whole thing squared minus 1. Therefore, the minimum value is going to be y is equal to -1, isn't it? So this is you guys have done in grade 10, 7. But let's see, find the derivative of this function. 2x plus 6, isn't it? In a maximum or minimum point, the equation of the tangent line will have a 0 slope, isn't it? Let's head back to 0. X equal to -3. Find out y when x equal to -3. -3 squared plus 6 times -3 plus 8. 9 minus 18 plus 8. So 17 minus 18, which is -1, isn't it? Now, let's going back to where do we see optimization. Let's going back here. Tin fish. Let's see. I'm going to create a tin fish like this. What do you think about a tin fish comes like this rather than having this? So let's go back to Swati. I can still put the same amount of tin fish inside both. Right? Which one do you prefer? Option 1 or option 2?
2.
Why?
It's easier to get out.
Oh, yes, easy to get out. That means easy to take the tin fish out. Absolutely. You can open it. Otherwise, it's like going to be protocol, right?
What kind of pan is that?
This is protocol. Have you ever
It
seen
looks like a science test tube.
whatever you want to call it? Okay. So So Swati say it's easy to check it out. Okay, it's looked like that she actually helped mom in cooking. Did you? Okay, so it's easy to check it out. Other than that, what are the benefits? Pranit.
Said it was 10 fish, right?
Yes. What are the benefits? One, she said is easy to open. Of course, the other one is going to be, the opening is going to be tough because you need to have that opener to go around. There's no way you can go around. Okay, go back to Varani. Varani, what did you think? Which one is the best option and why? What?
It's hard fish inside of it, so
What?
Isn't there already, fish?
Putting the fish inside?
No, because you said it was 10 fish.
Yeah.
That means it's already going to be inside.
Yeah, but which
So
one?
It would be easier to open, yeah.
Easier to open which one?
The second one.
Okay, other than that, what is the benefit? Okay.
It's flat. Put it there and open it like this. That one you have to fold. And if your hands are
All right. If you really look at it, guys, for this one, you need more material to packing. More material. Here you got a less material. You got a less material. The amount of tin fish I'm going to put inside the same amount of tin fish you can put. Same volume, right? But what we need to do is we need to minimize the packaging when it comes to our businesses. That's what the Costco, what it does is they just pack them in a bulk. So less packaging, therefore the packaging cost has been traded over on the pricing of an item. So if you see the unit price in Costco is cheaper, isn't it? So one item like that. There are so many other places that we want to see the optimization, right? What is the closest route to go from A to B, right? So what we're going to do, how we're going to find out, how we're going to find this, or how we're going to solve this problem. So algorithm for solving optimization problem. Read and understand the problem. Draw the diagram always if possible. Assign variables and restate the restriction. Write relation between those variables. Identify the variables you need to minimize or maximize. Use the relation to express the dependent variable as a function of single variable. Find the extrema. We know how to do this. Check the extrema to satisfy the condition. We also see that. We're going to learn that too. Find the value of the variable that satisfies the extrema. Write the conclusion statement. Look like the recipe is long, but it's pretty easy. Let's go back here. Find two positive numbers with a product equal to 200, such that the sum of one number and twice the other number is as small as possible. Looks like crazy. So what do we do first step? I take 0.25, 0.5 marks out. What do we need to do? You're coming from the level 4 class.
Okay. Wait, what? He's in level 4 class?
I'm just making fun of his teacher. The teacher show level 1 solution, level 4 solution.
I lost 45 marks for not writing on
You just ask my other kids who lost the marks.
Really?
Danushan, ask him how he losing the marks for writing, not just drawing. Okay, first step. What is the first step, Swati?
You write the information you're given.
Abhinesh?
First, make an equation that equals to 200.
You lose 1 mark. You already lose 1 mark. Let's go back to Varani. Varani. Let statement. Let the numbers be. Let the numbers be X and Y. So 0.25 marks your teacher can assign communication. Find the two positive numbers with a product equal to 200. Yes, we write the equation. And the sum of the one number plus twice the other number. The sum, let's call this S. But right now the sum is in 2 variables, isn't it? So the sum is right now in 2 variables. Sum of these numbers, one other number, twice the other number. So you guys see that? Sum is in 2 variables. Do you guys see that? Can I make that into 1 variable? Is there any way I can make the sum into 1 variable based on the information? We can isolate for the Y.
For one of the.
So Y is going to be 200 over X, isn't it? I guess following that? Yes? So therefore,
Yeah.
sum is going to be just in terms of x plus 2 times y is 200 over x. So your s of x is x plus 400 over x. Makes sense? Here's what I want you guys to find out. Find s prime of x, set back to 0, solve for x. I'll be back. That's your step. That is your first step to find the critical points. You didn't open the big box, right? You didn't open it.
Oh, you can't?
Yeah.
Nice.
Celebration.
Celebration conferences. So everything
It's supposed to go.
You guys are gonna do it if it's just motion.
Honestly, I don't know. I'm not even paying attention right now.
To make it easy.
What? I'm we are doing this wrong. Huh?
You have an
All this drugs. Look how bad it's gotten. I've been like working my nose so much for the past week that since it's cold outside too, it dries up and it comes out as blood too. I'm just gonna wait for him to do it. 'Cause I did it. I erased it because I got no answer.
Put one answer.
I don't think I did it right, to be honest.
So your physics teacher said chapter 3 from the Nelson textbooks when you're on the test.
Yeah.
Most of the teachers doesn't come back to the unit jet at school, so it's kind of weird how he expecting. Because there's a lot in chapter 2 to learn to come to chapter 3. Anyhow, all right, who has the value for x? So you're solving the calculus problem in the calculator.
No. I made a mistake.
Let's see how far you progress.
I think my answer's wrong. Very wrong.
There we go. Okay, now I got it.
So you say the derivative of x is going to be 0. Derivative of x is 1, isn't it?
Oh.
Alright, here, wait.
Abhinesh. Hi, Abhinesh.
Yeah.
What did you get for x, sir, when you set back to 0?
I'm still doing it, but I'm done the derivative part. I'm isolating for the x right
Oh,
now.
I see what I did wrong. Oh.
What are you doing, sir?
I
X
switched
prime
it.
x.
I switched it back. So it's what's the derivative? Minus 400 no, x minus 200.
I'm confused completely what you have done. Minus 400. Oh, I see. Oh, I see. X to the power of minus 400. Okay. Yeah. And then x squared. All right. So there's a 2 possible answers. It's going to be minus 2 and positive 20.
Yeah.
Okay. Let's find a s prime of x. 1 plus. You can imagine this one, guys. X plus 400 to the power of x to the power of negative 1, isn't it? So if they find the derivative of s prime of x, derivative of x is 1. You bring that minus 1 to the front, times it by 400, x to the power of minus 1, minus 1, minus 2, isn't it? So which is going to mean 1 over negative 1, 400 over x squared. We want that to be 0. So that means 1 is equal to 400 over x squared. So cross multiply, x squared is equal to 400. Move the 400 to the other side. X is equal to 20, or x equal to negative 20, isn't it? Are you following that? Okay. Now we need to go back to a little picture here. So the question here is, we got 2 x values, but does 2 x values will be minimize the, what is it called? Do you guys think both x values will be minimize the sum, or only one particular x value is going to minimize the sum? What do you guys think? That's what we need to discuss. So we're going to go back to see how we should be able to handle that part. Just give me a moment. Okay. So we got 2 values, but there's only one value that's supposed to be working. So let's going back to see how to do it. Let's think about a function. Let me think about a function. Function has a slope of 0 here, isn't it? But let's going back to the right side of the 0. If you go to the right side of this, we got a slope is positive. Left side is slope is negative. Did you guys see that? This tangent is 0 here. The left side is negative slope, right? I mean, left side is positive slope. Right side is negative slope, isn't it? So in other way, if A is the critical point, if the slope is positive here, slope is negative here, you should have a maximum point. If A is a critical point, you have a negative slope and positive slope. The left side is negative slope, right side is positive slope. you should have a minimum point, isn't it? Make sense? So what we want to do is we want to test it. We want S prime of X. What is the S prime of X? 400 over X squared, isn't it? Let's substitute. Let me find out whether I'm going to have a positive value or negative values. S prime of 20 plus, 20 just plus. So 20 plus means if I substitute something 20 plus, this fraction is going to be less than 1, isn't it? So 1 minus something less than 1 is positive. Slope. Makes sense? S prime at 20 minus. Let's say I substitute 19. When I substitute 19, 400 divided by 19 squared is going to be less than 1. I mean greater than 1. Imagine 400 divided by 19.99 whole thing squared. Let's do that math. 400 divided by 19.99 whole thing squared. It's just going to give me 1.001. 1 minus 1.001 is going to be negative, isn't it? So let's going back here. At 20, you got a positive slope, you get a negative slope. You're going to have a maximum value, isn't it? What they really want is they want a minimum. So let's test that out with the negative 20. S prime of negative 20. Well, if I do X prime of negative 20, 1 minus 400 over negative 20 to the right side. If I move to negative 20 to the right side, I'm going to going back to 19, negative 19 something, isn't it? So negative 19.99 squared, it is going to be give us negative value. S prime of, so that is positive. Negative minus 1 over 400 over negative 20.001 whole thing squared is going to give me a positive value. So negative slope and positive slope. At negative 20, I get a negative slope and positive slope. I will get a minimum. So therefore, the numbers are negative 20. And I think we can find out. X times y is 20 mean y must be negative 10, isn't it? I mean positive 10. So product of those two numbers must be 200. Right? Avinash, are you following that? So what's happening?
Yeah.
All right. So we got two values, and then exist. And then something that we need to talk about. Find two positive numbers with the product equal to 2. Oh no, they want the numbers to be positive. They want both numbers to be positive, isn't it? So if they want both numbers to be positive, this option is not going to work. All right. Now, let's going back to the condition, because the conditions say sum of the number smallest as possible. So how come I didn't get the smallest possible here? Let's check it. 20 plus. 20 plus mean 21. That's going to be positive slope. Oh, I made a mistake. 20 plus mean to the right side of the 20, guys. Right side of the 20, I need positive slope. Left side of the 20, I need to get a negative slope. Bernie, you're from the level 4 class. What you doing, man? So we don't need to check anything. We don't need to check anything here. We can clearly see at S is equal to X equal to 20. The sum will be minimized, isn't it? So are you following the picture? Therefore, the numbers are 20 and 10. Questions from the schoolwork? All right. I don't want to go to the next question. So you say there's a question from somewhere. Where's your questions coming from, man? Abhinesh?
Oh, I had a question for Unit 2, which was, I think it was question 14 on page 2.5.
2.5.
Which is page 106.
Page 106. I'm almost there. You say 15?
No, 14.
Find h prime of 2 given h of x. Sure, that's a chain rule. Let's do that. Where's your homework questions? Did you do that textbook problem? And then you know how to do all of them?
Not all of them. Because I just started teaching us 2.6.
2.6. There's no section called 2.6.
There was like an intro to like optimization apparently.
2.6.
Yeah.
Which textbook you is using? Nelson or McGraw-Hill Rising? Oh yeah, that's why. Okay. All right, let's do 15. You say 15, isn't it, sir? Oh my bad. He just asked me
14.
for 49. Keep on. Okay, 14. Given h prime of 2, and then what they want to find out. Find h prime of 2. So let's find h prime of x. We're going to use the chain rule. F prime of g of x times it by g prime of x. So h prime of 2 is going to be f prime at g at 2 times it by g prime at 2. F prime at what is g of 2? G of 2 is 3, isn't it? Time g prime of 2. G prime of 2 is minus 1. So we need to find out f prime of 3. So f prime of 3
Wait,
is,
so how do you know it's f prime g of x times g prime of x?
that's a
again?
chain rule. That's a chain rule, sir. That's a rule. That's a chain rule. It's a composition function, right? It's a composite function, f of g of x. You find the derivative of the big function, and then you go inside to find the derivative of inner function, right?
Oh, okay, yeah.
Now we need to find out f prime at 3. So let's find out at f prime at u, which is 2u minus 1. And then, 2u, not 2u minus 1, 2u. Then I want f prime at 3. So which is 2 times 3, which is 6. So you want f prime at 6. Oh no, that is already 6, what I'm doing. 6 times minus 1, which is going to be negative 6. Makes sense? Are you
So
following
you
that?
would just use the formula of the chain rule and then start working with that?
Yeah. And then I started to substitute the values I know. So far so good. No other questions from anyone?
I have one more question.
Yeah.
It's from 2.3, which is question. Wait, not 2.3. 2.4, which is page 98, question 14.
'96, '97, '98. Which one? 14. So they want the graph has horizontal tangent. Okay. I'll do it here. So if the graph has horizontal tangent, we're going to find out f prime of x there. Right. So before I find f prime of x, to make my life easy, let's rewrite the f of x nicely. So f of x is equal to ax plus b over x squared minus 5x plus 4. So from here, f prime of x, you're going to keep this guy on the x squared minus 5x plus 4 to the power of 2, right? X squared minus 5x plus 4. You find the derivative of that is going to be a minus, you keep ax plus b. Find the derivative of that is going to be 2x minus 5.
For
Makes
x,
sense?
do you sub in 2?
I didn't get. But now they say it has a horizontal tangent. So what does that mean? F prime at 2 is supposed to be 0. So if you cross multiply, we only need to worry about the denominator, numerator at 2. So 2 squared minus 5 times 2 plus 4 times a minus x is 2, isn't it? So 2a plus b times 2 times 2 is going to be 4 2 times 2 is gonna be, it's not writing. Okay. 2 times 2 is gonna be 4 minus 1 is -1, isn't it? Are you following that, sir?
Yeah.
2 squared is gonna be 4. 4 plus 4 is 8. 8 minus 10, -2. So -2 times A. And then -2 times A minus 2A plus B time -1 is 0. So moving back, -2A minus 2A. Oh no. So -2A minus time minus gonna be positive plus 2A and a minus B is equal to 0. So B is equal to 0, isn't it? Are you following that, sir?
Yeah.
Okay, now we know the point is 2 comma minus 1, but B is 0. So B is 0, I mean, so when I substitute 2, right? So f at 2 is also -1, isn't it? That's what it says. So if at 2 is -1, mean 2A.
Then you
is
sub it
0.
into the original equation?
Yeah, exactly. 2 minus 1 is 1. Time 2 minus 4 is -2. Supposed to be -1. So 2A divided by -2. So negative A is -1. A must be 1. B must be 0. You following that? So yesterday I gave a medal to Divesh for winning to come first 25th percentile in school for Canadian senior math contest.
Oh, you won it?
Yeah, but we put the picture first. We asked his permission to the newsletter, the principal newsletter that goes to parents too. And then later on, I think that the parents doesn't want the pictures, so it's one side. Diva's parents doesn't want his picture on there, so we're gonna remove it. All right, any questions? You have a question, sir? 2.4 question. 8. So there is no tangent have the negative slope. So f of 5x plus 2 over x plus 2, isn't it? 5x plus 2. So we want to find out f prime of x is always positive. So we need to prove f prime of x must be always greater than or equal to 0. That is what they mean by. So how do I do that f prime of x? X plus 2 whole thing squared. You keep the x plus 2, find the derivative of 5x plus 2, which is 5 minus. You keep 5x plus 2, find the derivative of x plus 2, which is 1. 5x plus 10 minus 5x minus 2 over x plus 2 whole thing squared. Gone. 8 over x plus 2 whole thing squared. What do we know about it? X plus 2 whole thing squared is greater than or equal to 0 always. And then, therefore, a divided by x plus 2 whole thing squared must be always greater than 0. Because your f prime of x is this function, isn't it? Do you think that function ever be negative? A positive number divided by a positive number, do you think it's ever being going to be negative? That's it. Makes sense? That's what he has to prove. He has to prove that function never have a negative slope. Makes sense?
Wait.
So
That one doesn't have a tangent.
it has a tangent, but the tangent never going to be negative. That
Sure,
doesn't
so
make sense.
Would that answer for that question be greater than -2?
Greater than 0. The question, sir, you need to prove the f prime of x is always positive, and we prove it because your f prime of x function is 8 over x plus 2 whole thing squared. So 8 is always positive. X plus 2 whole thing squared is going to be always positive or 0. So therefore, when you're dividing that number, it's going to be greater than 0. Oh, right?
Yeah,
you
but
do-
won't x be greater than negative?
So you need to understand the question, sir. The question, show that there is no tangent to the graph that have a negative slope. as long as we show this is not going to be a negative value, that's fine. We don't care about whether it is going to be undefined or not. All we need to show is this value is never going to be negative. Make sense?
Yeah.
That's it.
Oh, okay.
And then you can visualize it if you want to visualize the graph. So 5x plus 2. So this is the graph, 5x plus 2. So x is equal to -2 and then 5. So this is the graph. Right? So fx 5x plus 2, x plus 2. That's what the graph is going to look like. And then this is basically the function. And then we can prove the function is always going to be positive. Are you following that, Swati? Varani, you never asked any questions?
Oh, I don't have any.
All right. Anyone else? Yes, sir.
2.283.
Page 83.
I'm just wondering why it's kilometers over
All right, so page 83. 83. Which question?
19B.
19B. Find the rate of change of this distance with respect to the height when the height of the elevator is 200 meters. So if you really read that question, sir, it can be shown that from a height of h meter, a person can see the distance d kilometers. So the rate of change is going to be kilometer per meter, because the distance you can see in kilometer, we did this one in class.
I know.
Yeah.
I didn't get to
The
ask.
distance you can see is in kilometer from the height of from the height of a building, right? No other questions? You don't have any questions? Okay, so I'm going to show you the best way of learning. So I try to teach out of the school, and then I'm going through my content. Now, you need to practice every single question you on this textbook. And I would like to see a good student will have a sticky note that's coming out of the textbook. This question, I did it before the class, I don't know. Done. Same applying to any. So especially math, physics, chemistry. If you know how to answer the question from the textbook problem, guaranteed you will get 80% in about, guaranteed. And you all have a time. Absolutely, you all have a time. Unless you're going for a full-time job or part-time job. Right? You all have a time. If I have a time to teach and then teach at school and still mind marking, you all have enough time. Right, sir? No questions? I'm out of the curve on this. Abhinesh, any questions, sir?
No, sir.
All right. So if you don't have a questions, I can going back to my optimization. I like optimization. So let's go back to one more question. Are you ready? All right. If 2000 centimeters square of material is available to make the box with a square base and an open top, find the dimensions of the box that will give the largest volume. So open top mean you don't have a top, right? So material mean we need the material to pack. We need the material to just pack the covers and right, two sides and the bottom. So let's calculate the surface area. So surface area in terms of x comma h. So x times h, there are two of them, this side and that side. Okay. And then another x times h here. So I can say 4 of them goes like that. 4 of them is going to be x times h. The bottom is x squared. I don't need to worry about the top because the top doesn't have anything, isn't it? Make sense? How much is that equal to, Swati? Correct. 2,700. What is the volume of the box? X comma h. X times x times h, which is x squared times it by h, isn't it? We want a volume to be the largest possible. So we don't want the h. We want this to be in one variable. So 4x h is equal to 2,700 minus x squared. H is equal to 2,700 minus x squared divided by 4x. So x squared times 2,700 minus x squared over 4x is going to be a volume in x. That is going to be became 2,700x minus x cubed, isn't it? How long that's that, Ranit? We want a v prime of x to maximize 2,700 minus 3x squared. We want that to be 0. Well, of course, you're gonna get a plus or minus 30. But do I care about a negative 30? No. X is equal to 30. How do I find the h? H is 2,700 minus 300 squared times it by 1 over 4 times 30. If I am right, that's supposed to be also 30. Oh yeah, 15. Yeah, that's good. 15. So the height must be 15, bottom must be 30 by 30. Makes sense. Are you just following that example? All right, that's for you guys today. I am far ahead. Technically, I finished chapter 3. Chapter 3 is high order derivatives. Look at the textbook, sir. High order derivative, finding extreme values, and then optimization question. And the last one, optimized questions, question on science and business. Where's your textbook, man? Okay. All right, guys. That's for you guys today. We're still going to have a class next week. That's the time you will have 1 week free, no testing quizzes. It's March break. When I will have a class. So I will clear out the chapter 3, most probably next week. And then if we clear out,
I want to clear out.
we can start. What?
I want to clear out my.
I have a solution for that, sir. Ask your mom to make the best school.
She already did.
All right. Any questions from you guys?
No.
All right. You guys are dismissed.
Thank you.
Okay.
Bye.